Good morning, grade 12s. Welcome to Technical Mathematics. Today we are going to be discussing algebra. That is the topic that we are going to be discussing. And then it's a very nice Saturday. I hope you are still well and you are still pushing your studies, preparing for this coming final exam. And then before we can start, I just want to advise learners that they should get the examination guideline as well as the previous question paper and revise with those question papers. And then for the examination guideline, just to go through it and just to read what are the things that you need to know before you can go and write the final examination. That's all. And then we can now start and see what are we going to be discussing under algebra. All right, under content, algebra is one of the topic for paper 1, and then it contributes 50 plus or minus 3 marks. And then under algebra, we'll be focusing on quadratic equation and inequalities, simultaneous equations, changing subject of the formula and solve, and then binary numbers, nature of roots, exponents and sets, logs, and of course the last one is complex numbers. Right, those are the topic that we'll be discussing under algebra today. Then before we stop time, I think we can just start and see what are we going to solve. All right, you can see it say the argument of a complex number, and now in this case we will be dealing with the argument where we are going to be calculating the argument. And then from there we have this diagram here. I just want to show you something. You can see there is angle there, which is angle theta, and the terminal arm on the second quadrant. And then this side, which is x-axis, we then call it it's a real axis. And then of course this one is going to be imaginary axis. They're saying there are two important quantities associated with the line segment OP. And first is the length of OP known as the modulus, meaning the length of this OP is called modulus, or we can call it R, that modulus. The angle made by the line OB is with the positive real axis, also known as the argument, meaning this angle here, which is formed between this real axis and this terminal arm, theta, and then we call it argument. Then that is the angle that we'll be calculating with you. The complex number, we know it's Z equals to A, which is the real part, plus B, which is the imaginary part, I. And then this is the formula that we are using, this is the formula that we are using to calculate the angle theta, or the argument, where we say this tan-second function B over A. So this is the way how to calculate the angle. And then from there we have, let's see, let me just move this. And then I also did explain A is the real part and B is the imaginary part. Okay. So let's see on how do we go about the argument. Calculate the argument theta of the complex number 1 plus I. Then solution. Now before you can calculate the argument, you need to draw the rough sketch of the eigen diagram so that we can be able to see where is our terminal arm, because that is really very, very important. We need to know the quadrant so that we have to calculate that argument. And then from there, we have to determine the point first. And we can see the ordered pair is 1:1, which is x is 1 and y is 1, where a equals to 1 and b equals to 1. Then obviously this terminal arm is going to be on the first quadrant. So whatever the angle that we are going to be calculating or getting is going to be an acute angle, which is less than 90. Now we first have to write the formula tan theta equals to b over a. And then from there you substitute the value of b, which is 1, the value of a, which is 1. And then you divide with tan, then this is what you're going to be having. Then you press shift tan on your calculator 1, then it's going to give us 45 degrees, meaning this angle theta is 45 degrees. So then we have calculated the argument. So that's how we should calculate the argument. Another question, calculate the argument of z equals to -4 plus 3i. Then the solution on how do we calculate this one. First, draw the rough sketch of the Eigen-diagram. Then let's have a point. That point is -4 and 3, where x is -4 and then y is +3. Then our diagram is going to be on the second quadrant. And then we all know in this quadrant we have 180. Then we try 180 minus. Remember from the trig ratios, from the reduction, from the reduction, it's 180 minus. So by the time you're going to calculate the argument, then you must start with 180 minus, because the terminal arm is on this quadrant. Now you first have to write tan theta equals to b over a, and then you then substitute the value of b, which is 3, the value of a is -4. Then you have -3 over 4. Then you divide with tan, actually supposed to be second function there, supposed to be this. Then we are going to say 180 minus, say shift tan 3 over 4. Now every time when you calculate this angle, we call it a reference angle, we always ignore negative. You can see there was negative there, then now there's no negative inside this bracket. So every time when you calculate the reference angle, we ignore the negative sign, right? And then once you ignore the negative sign, this is what you're going to be doing. 180 minus tan, shift tan 3 over 4. Then you just press your calculator, then it's going to give us 143.1 degrees. All right. And then let's go and try to calculate another argument. We have -1 and -3i. First, draw the rough sketch of the Eigen-diagram. It's very important. And then now we have a point which is -1 is to -3. And then we can see that that point is on the third quadrant. You can see in third quadrant we have 180 plus. This is 180 plus. If you remember from the reduction, it's 180 plus. A decrease. Let's see. First, you have to write tan theta equals to b over a. All right. And then you then substitute the value of b and a. And then this is what you're going to be having, which is a tan theta equals to square root of 3. And then you say theta equals to 180 plus shift tan square root of 3, because now the terminal arm is on the third quadrant. Then you just press your calculator, the answer is 240 degrees. So that is the angle. This angle is 240 degrees. Okay. And then we then proceed draw a rough sketch of the Eigen-diagram. Then we have a point which is square root of 3 minus 1. Square root of 3 minus 1. Draw the Eigen-diagram. We can see that it is on the fourth quadrant. It's on the fourth quadrant. And then there is a mistake there. This is not negative. This is not negative. This is not negative. Square root of 3. It's supposed to be positive because x is positive there. You can see that this is positive, you can see it's positive square root of 3. So they just put this negative mistake. And then from there, you then have to write tan theta equals to b over a. And then this is what you are going to be having 1 over a negative 1 over square root of 3. And then remember, since this terminal arm it is on the fourth quadrant, then we have 360 minus shift tan 1 over square root of 3. Don't forget that you always ignore this negative when you are looking for the reference angle. You ignore the negative. Then you just press your calculator, and the angle that we are looking for is 330 degrees. So that is the angle we have obtained. So that's how you should now calculate the argument. So what is important for you to be able to calculate the argument is to know the terminal arm. Where is the terminal arm? Which quadrant the terminal arm lies? Then you take it from there. If it's the second quadrant, 180 minus. Third quadrant, 180 plus. Fourth quadrant is 360 minus. Okay, and then let's proceed. Trigonometric or polar form. The trigonometry or polar form of a complex number. The polar form of a complex number z equals to a plus b is z equals to r, which is the modulus. Remember earlier on we discussed around the modulus. We said the distance from O to P. We said O to P, the distance of this terminal arm is the value of R. And then of course in cos theta plus I sine theta, where we have from the trig ratios, we have cos theta equals to A over R. And then if you make A the subject of the formula, then you're going to have R cos theta. So instead of this A, you then substitute with what? With R cos theta. Now the same with sine. We have sine equals to B over R, which is opposite over adjacent, and then we then cross multiply to make B the subject of the formula. Then it say B equals to R sine theta. Then instead of this B, you then substitute with R sine theta. Therefore, we take out common factor as R, then we're going to have this. Now, if in this form, it is in the polar form or trigonometric form. So there will be a question that say convert this to the polar form. So this complex number, or we sometimes call it rectangular form. So we move from rectangular form to polar form, and then vice versa. They can give you in terms of polar form, then you have to convert it to a rectangular form. But that one will then explain it later. But now we are going to be learning on how to convert it from rectangular form to polar form. All right. And then they are saying the distance r modulus z, distance of the terminal arm. That's what we explained. And then the formula that we are using to calculate that is r equals to square root of a squared plus b squared. And then theta is called the argument. Remember, we did explain, we did calculate the argument. Then this is the formula that we were using to calculate the argument. All right. And then let's proceed. Write the complex number, or we can say write the rectangular z equals to 1 plus I in its polar form. Now the solution, and this is the complex number or a rectangular form, and then we take the value of a, which is positive 1, the value of b, which is 1. And thereafter you calculate the modulus. That's the first number. That's first the value of r. We have to get the value of r, which is then substitute the values, and then from there you press your calculator. Then the value of r is square root of 3, and square root of 2. After determining the modulus, you determine the argument. That's step number 2. And then remember, for you to be able to determine the argument, we need to know which quadrant, right? And then this is going to be the formula. Then you substitute the values, and then the answer is going to be 45 degrees. But we remember this one we did it earlier on, where we have seen that the terminal arm is going to be on the first quadrant, because A is positive and B is positive, so they are all positive in this quadrant, and then hence the angle delay is 45 degrees. And then we did not add with anything, or we did not subtract it with anything. All right. Thereafter, determining r and theta, then we can now write the polar form, and then this the standard formula for polar form. Then we then substitute the values, and then that's the answer. And then remember, we've got another way of writing polar form, that says z equals to r, and then this is going to be the angle, right? Where you just have to write square root of 2, and then you just put 45 degrees inside this. So this is another way of writing it. Or we have another way that says z is equals to RC theta, this one, and then where you are going to say square root of what? Square root of 2 sine I cos I s, and then this theta is 45. So we have a three way of writing the polar form. You can write it in this manner, or this one, or the last one. All right. Okay. Let's proceed. Write the complex number this in its polar form. We still have this other question where we have to convert it to polar form, and then you write the complex number. The value of A is 1, the value of B is negative square root of 3. First, we have to calculate the modulus. Let's now write the formula. Then we substitute the values, the square root of 4, then the answer is going to be equals to 2. So that is value of R. That's step number 1. Step number 2, you then have to calculate the argument, the theta, and then this one to happen. And then because now this actually, let me just check first. Actually, this is supposed to be negative here, and then this is negative there, then this negative there. So if both A and B are negative, therefore this is going to be on the third quadrant, and then we know on the third quadrant it's 180 plus, hence you can see there's 180 plus there. All right, and then you just put everything inside the bracket. Actually here we're supposed to put a positive this value, but now it's going to be positive anyway. Negative divided by negative is going to give us a positive, because I clearly said that we should ignore the negative when you are looking for the reference angle. All right, and then after pressing the calculator, then you're going to be getting 240 degrees. So that is the angle we're looking for. Then you write the polar form, the standard form of a polar form. Then you just substitute the values. Then this what you have. Then you will get the full marks. Right, polar, this to rectangular. Now we remember earlier on I did explain that we'll do vice versa, and then we were converting from rectangular to polar. Now we change. We then have to write it from polar to rectangular form. Let's see on how do we do that. Now the example, we have write the following polar form, which is this to rectangular form. All right, now solution, how do we start? This the polar form, and then now we just press your calculator. You say cos 45, which is square root of 2 over 2, and then sine is square root of 2 over 2. And then in some other calculators, when you press cos 45, it will give you 1 over square root of 2. So 1 over square root of 2 is the same as square root of 2 over 2. So those the They are the same. And then you just have to press a calculator, and this one from there you're going to open your bracket with this +5 outside, and this one you're going to be obtaining. You can see now it is in this form. You can be able to see the value of A, which is 5 square root of 2 over 2, the value of B, which is 5 square root of 2 over 2. So now it is in the rectangular form. Given z equals to -2 plus I, calculate the modulus, which is z, that's number 1. Number 2, we have to calculate we have to determine the argument, which is the theta, now expressed in polar form. Now remember, we've learned that. Let us try to answer this question, because there is no way you can be able to convert it to polar form if you don't have the modulus, if you don't have the argument. You first have to calculate those. The modulus, then you just substitute the values there, then it gives us square root of 5. Then we have the square root of 5. Let's calculate the argument, the angle. Then we can see that according to the value of A and B, this is going to be on the second quadrant. And then on the second quadrant is 180 minus. And then you just say shift turn. Then you put in positive here. You put positive value there, because you can see A is -2 there. Let me just say A is -2. B is what? B is 1. All right. Let me just remove this. My pen does not want to write very nice, but anyway, it's fine. Just press your calculator, then you're going to obtain 153,43 degrees. That is the angle that we're looking for. And then now you write it in this manner. R, we have square root of 5, and then this angle we have what? 153,43 degrees. So this is how you should now write it in a polar form. Given, now you can see that it is given in terms of polar form. It's expressed z in rectangular form. That is the number 1. Let's see on how, and then from there you write down the conjugate of z. I hope you still remember on how do we apply the conjugate. It's very simple, easy, and we'll talk about it. And then the solution on how do we express z in terms of a rectangular form. Then you write this 1, then from there you just open it like this. Then we know the angle that we are having, the angle for pi over 4. Now you can see this angle, it is in terms of radians. And then we know that pi, if we have to convert it to degree, then it's going to give us 180 degrees, all right? It is going to give us 180 degrees. So it's 180 degrees divided by 4, then it gives us 45 degrees. Then now we can see this in terms of degrees, and then it's fine. And then you just press your calculator. Then after pressing calculator, you then open bracket with this +4 outside. Then it's going to give us 2 square root of 2 and plus 2 square root of 2i. So that is in a rectangular form. And then step number 2, conjugate. So you just change the sign of bi. You just change the sign of bi, and then it's going to be -2 square root of 2i. So every time when you say conjugate, write the conjugate. Just change the sign of the imaginary part, which is bi. All right. Solving the equation with the complex number with 2 variables. Solve for x and y. Now, in this case, we will be solving x and y. So now it's a complex number. So we are going to be learning on how do we solve such. Now first we have this question that say 8 plus 3yi equals to 4x plus 6i. Now in order for you to solve this complex number or the value of x and y, then you are going to be grouping those that does not have I, and then you then group those that have I, right? Then you can be able to solve the value of x and y. Then it's very clear from this question that this 8 is going to be equated with this 4x, and then this one is going to be equated to this one, all right? And then let's see the solution if that is the correct way. That's correct, because we're going to say 8 equals to 8, 4x is correct, that's number one. And then when you solve the value of x, of course, we're going to be dividing with 4 both sides, and then 8 divided by 4 is 8, 2, then x equals to 2. Then we have solved the value of x, and then you then equate the next one, 3yi equals to 6i, then you just divide with 3i. If you divide with 3i, then the value of y equals to 2 as well. The value of y equals to 2. That's how we should now solve these x and y. And then we have got another one. Let's see. Solve x and y if this is what we are having. Now, this one is not the same with this one. We can see on the right hand side we've got bracket. Then before we can now equate this, we have to open this bracket and add the like terms first. Let's do that. Let's see. You then open the bracket, then you can see that's 9 times 3 is 27, 9 times I is 9 or I, then negative 7i multiplied by 3 is negative 21i, and then negative 7i multiplied by positive I is negative 7i squared, all right? And then the third step, now you should remember that I squared is equals to negative 1. Now in a place of y squared, I squared I mean, you can see we replace it with negative 1. There's no I squared there. Then we did add this because these are the like terms. And then we said 9 minus 21i, which is negative 12i. And then this I squared is negative 1. And then this is what we are having. Then we are going to equate this one, and then we then equate this one. All right, you can see that the value of x is 34, and then this one you're going to be dividing with I both sides, and therefore the value of y is equals to negative 12. So that's how you should solve these equations of complex numbers, x and y. So remember, when you have a bracket, you first have to open the bracket. Then you equate those that they don't have the I, and then those that have I together, so that you can be able to solve the value of x and the value of y. All right, but they sometimes write solve the value of a and b, not I. It's not always the case that it must be x and y. It can be two variables, and then but the procedure is still the same. Those you just equate those that does not have I, and then those that have I. Then you can be able to solve everything now. All right, if z1 equals to 3 minus 4i, and z2 equals to negative 1 plus 7i, 1, determine z1 times z2. actually supposed to be 2 here, not 1. Sorry, z1 times z2. And then just a note that you should remember I squared is equals to -1. Then you have these two brackets, then you have to multiply them together, and then you need 3 minus multiply by -1 is -3. 3 multiplied by 7i is 21i. -4i multiplied by -1 is +4i. -4i multiplied by +7i. Then give us -27i squared. And the third, remember, instead of writing this I squared, then you replace it with -1. Then from there you add these two like terms, then they are going to give us 25i. And thereafter you then write it, it's going to be -3 plus 27, because this is going to give us +28. It's going to give us +28, and which is going to give us 25 plus 25i. All right. So if there was a question, say we should write the conjugate of this, then we're going to be saying 25 minus 25i. But now that it's not the question, I was just trying to remind you. Example of solve for x. Solve for x. Now remember, we are still under algebra, and I did explain that we are going to be solving the quadratic equations. All right, now let's solve for x. Number 1, -2x into x plus a into 3 minus this equals to 0. Let's see on how do you calculate this one. And now the fact that the right hand side is equals to 0, then we can now go straight and solve this one. Then it's going to be -2x equals to 0. That's the first one. Or x plus a equals to 0, or 3 minus x equals to 0. Then we transpose. And then if you divide with -2, it's still going to give us 0, x equals to 0. And then this one, x equals to -3, -a. And then this one is going to give us a positive 3. So we just solved the value of x. So it's quite simple and easy. And then number 2, 2x minus 6 minus x squared, correct to 2 decimal places. Now, this question, normally you'll find it during exam, then where you have to solve the value of x. So if you come across this question where it has a instruction next to it saying correct to 2 decimal places, you must know that you are going to be dealing with the quadratic formula, because this quadratic does not have vectors, so you have to use the quadratic formula. But first you need to rewrite it and put it in a standard form, because you get a mark for this. So just to transpose this negative x squared this side and this positive 6 is that side, everything on the one side, then it's a mark. So make sure that you first have to rewrite in a standard form. Thereafter, you can see the value of a in this case is 1, the value of b in this case is 2, and the value of c is -6. So sometimes learners, they tend to not to include this negative. They will write c as +6, whereas it must come with a sign. And then you write these are the values: a equals to 1, b equals to 2, and then c equals to -6. And then you write the quadratic formula, and you substitute correctly the value of a, the value of b, and c. Then you just press your calculator, and then the value for the first one is 1,65, and then the other one is -3,65. So that's how you should calculate the quadratic. You should calculate or determine the value of x using the quadratic formula. All right, solve for x. We have another one. X minus 2 into x plus 3 equals to 6. Now let's solve this one. Now remember earlier on we had a question that is similar to this one. Now that one, remember on the right hand side it was equals to 0. Then we just solve the value of x without factorizing, just solve the value of x. But now the fact that this one is not equals to 0, you can see it's equals to 6. Then if that is the case, then we'll have to reopen the bracket first and take this positive 6 to the left hand side, and then we then start to factorize it because it must be equals to 0. Let's see on how do we do that. Yes, of course, after opening the bracket, this is what you are going to be having. And then this positive 6, if you take it to the left hand side, it's going to give us negative 6. Then you just add, then it's going to give us positive x squared plus x minus 12 equals to 0. Then from there you factorize it. Then it's x plus 4, x minus 3 equals to 0. Then you solve the value of x, which is x equals to negative 4 or x equals to 3. So that's how you should solve the value of what? The value of x. All right. And then number 2, we have x equals to square root of 2x minus 1 plus 2. Now, I always advise learners when answering this type of question, if what we are in need, you can see from distance, this one we are calculating the value of x, and then that x is inside the square root. Now, how do we go about this question? Now, I always say to them that where you see the square root, everything which is not inside the square root on that side, we remove it before we can square both sides. Now let's see, there was 2 on the right hand side, then we had to transpose it to the left hand side, hence you see x minus 2. Then the third step, then that's where you're going to square both sides to get rid of that square root. And then we are left with 2x minus 1 because this square root, remember, square root is the same as half. So half times 2 is 1. Then this side is say x minus 2 all squared. And remember, we have to open 2 brackets and multiply up and apply what you call a FOIL. Then this is what we're going to be obtaining, x squared minus 4x plus 4. Then you are going to take this one to the left hand side. Then we add, subtract. Then this is in a standard form, which is x squared minus 6x plus 5 equals to 0. And then from there you solve the value, then you factorize, these are the factors, and then you solve the value of x. Then every time after solving the value of x, you have to test your answers, because not all answers are the solution. For instance, if you can take this positive 1 and then substitute here and then there, it must give the left hand side to be equals to the right hand side. Then let's see, if you say 2 times 1 is 2, 2 minus 1 is 1, square root of 1 is 1, 1 plus 2 is 3, and then this side is going to be 1, so 1 cannot be equals to 3. Hence we say x should not be equals to 1, because 1 is not a solution. Then if we take 5, let's put 5, we have 5 on the left hand side, let's come here, 2 times 5 is 10. 10 minus 1, 9. Square root of 9, 3. 3 plus 2, 5. So meaning 5 equals to 5. Then only x equals to 5 is the solution for this question. All right. And then the other one, oh, sorry, let me just remove this, sorry. This one and this one. Let's move this one. All right. Solve for x. Let's solve for x on this one. I don't know what is really happening with my pen. All right, thank you. Now let's factorize this one. You can see it's a polynomial because it has x cubed there. Then the first step, what you have to do, you can see that we have a common factor, and then our common factor in this case is x. You take out x as a common factor. Just after taking x as a common factor, inside the bracket, you can see we are now having the quadratic. Then we have to factorize this quadratic, and these are the factors, which is 6x minus 5 and 2x plus 1. Therefore, we then solve the value of x, and x equals to 0, that's number 1. And then when you solve x here, x minus 5, which is going to give us 5 over 6. And then this one, when solving the value of x, it's going to be negative half. So that is the value of x. Now the second one is this one. Now because it's not equals to 0 on the right hand side, then we have to open this bracket and then bring this positive 5 to that side. Let's do that. And then you just open the bracket and then you just get a mark, just put it in a standard form. Then we can all see that we don't have factors to solve this question, but now we can use the quadratic formula. Let's use the quadratic formula. We can see that we have substituted the values there, and then the positive one is going to give us 1,45, and the other one is going to give us negative 3,45. All right, solve for x again. X squared minus 5x minus 6 equals to 0. And then we have to get the factors. And normally the first question or under solve for x, it must have factors. It has factors. You just have to learn on how do we determine the factors. And then the other thing is that you find that other learners are struggling to get factors. Now, if you struggle to get factors, you can use the quadratic formula, it's fine. But if you have used the quadratic formula in a question where we have factors, therefore you won't be able to get that mark for getting factors. Yes, the answers are going to be correct, and then but we are going to be losing that mark for factors. But you can still use the quadratic formula just to help you to get the factors. For instance, if you put this one and then you put it in your calculator using the quadratic formula, first you're going to get the answer as 6. Then after getting the answer as 6, what are you going to do with that 6? It tells you that x equals to 6. If that is the case, then it's going to be x minus 6. That's the first bracket. And then the other one is going to give us xs. You're going to get negative 1. Then if you are having negative 1, then you know if we transpose that negative 1 to the left hand side, it's going to be x plus 1. That is the second bracket. You can see from the solution, these are the bracket. This is the bracket. Then there is a mark for that. There's a mark for that to get the vectors. So if you use the quadratic, then you're going to forfeit that mark for getting vectors. All right. So let's make sure that we get the vectors and then the correct vectors, and then even the sign must make sure that the sign are correct. Number 2, we have this one where we had to get rid of the square root because what we are in need of is inside the square root. All right, so every time when you are calculating or solving a variable that is inside the square root, you must introduce squaring both sides, right? Now, and I also explained that before you can square both sides, make sure on that side where you see the square root is only square root, not any other thing. Anything which is not inside the square root, you are going to be removing it, and then by transposing or by dividing. So it will depend on the question. But now you can see this one, it's fine. On the left hand side, we have only square root. Then you can see the second step, we just squared both sides. Then after squaring, we are now having x plus 3. Then here we're going to apply a FOIL. Then it's 1 plus 2x plus x squared. Then you transpose this to the side, it's going to give us 0 equals to x squared plus 2x minus x plus 1, negative 3. And then 0 equals to x squared plus x minus 2. And then from there, you then factorize. And then after you factorize it, it's going to give us x minus 1 and the x plus 2. Then these are the values. Then I repeat, after solving this one, you have to test your answers as whether the left hand side is equal to the right hand side. If you take this positive 1, and here it's 1 plus 3, which is 4, square root of 4 is 2. And if you put 1 here, it's 1 plus 1 is 2. So the left hand side is equal to the right hand side. And then let's go for negative 2. Then it's negative 2 plus 3 is 1, square root of 1 is 1. Then 1 plus negative 2, so the answer is going to be negative 1. So negative 1 is not equal to positive 1. So it's wrong. Then hence we are saying x should not be equal to negative 2. So that's the correct one. Solve for x and y simultaneously. 2y plus x equals to 3, that is the first equation. And then the second one, y equals to x squared minus x, that is the second That is the second equation. Then under solution, this is what we're going to be putting. Now, remember under simultaneous, we normally have to create the third equation. But in this one, there's no need for us to create the third equation. Why? Because if you can look into second equation, already y is the subject of the formula. So that tells us that when we substitute, we're going to substitute equation 1 to 2, meaning where we see y, then we're going to be substituted with x squared minus x. And then you can see substitute equation 2 into 1. Then here, instead of y, you write x squared minus x. Then from there, you open the bracket. And then you add the like terms. So the standard form is going to be 2x squared minus x minus 3 equals to 0. Then from here, you then start factorizing. I repeat, if you don't know the factors, use the quadratic formula. But now to help you to determine the factors, then you're going to get the other answer as 3 over 2. And then once it's 3 over 2, then it's going to be this 3 over 2. Then you just cross multiply. It's going to be x. It's going to be x equals to 3. And then from there, you take this 3 to the left hand side. Then it's going to be 2x minus 3. That is the first bracket. And then here we're going to get x as -1. Then if you take this -1 to the right hand side, that is going to give us x plus 1. That is the second bracket. Then you just solve the value of x. The value of x is 3 over 2, and the other one is -1. Now, the y corresponding values, we're going to take this 3 over 2 to one of these equations to determine y. And then I always advise learners, they must use where y is the subject of the formula, this one. But now, all right, you just substitute the value of x, because the first equation, you'll have to transpose, divide before you can get the value of y. And then sometimes you end up making some mistakes in the process of dividing or transposing. And then when you substitute the value of x of 3 over 2, then you're going to get 3 over 4. When you substitute the x as -1, then the value of y equals to what? Equals to 2. Solve x and y simultaneously. The first equation is x plus y equals to 2. The second equation is x squared plus y squared equals to 4. Then just put them here. the first equation, the second equation. Now you can see from these two equations, we'll have to create a third equation because we don't have anything which is the subject of the formula. So now every time when you have to create a third equation, you have to look to equation which is it's very easy to make any variable the subject of the formula. So it's not always the case that you will find x and y under simultaneous. They sometimes use other variables. Now you choose between y and x, which one you want to make the subject of the formula. Then we choose y, then we're going to transpose this positive x this side, hence we are having y equals to 2 negative x. That is the third equation. And then others, they will use what? You will use x as the subject of the formula. It's still fine. You are going to have the same answer. Now, since we have created the third equation from equation 1, then when we substitute, we are going to substitute equation 3 to 2. Where we see y, we're going to substitute 2 minus x. And then you can see this what we did. And then from there, you just open the bracket, you add the like terms, and then this is the like terms. This is in the standard form. And then you get a mark for that. Then from there, you can simplify it, it's fine, which is x squared minus 2x minus 15 equals to 0. Then you factorize it, x minus 5, x plus 3, solve the value of x. Then you take the first value of x, you substitute to one of this equation, but I always advise you to take the third equation because already y is the subject of the formula. You just substitute the value of x here, then 2 minus 5, which is minus 3. This is minus 3. And then you take x, negative 3, so it's going to be 2 minus 3, which is positive 5. So that's how you should solve the simultaneous equations. Very simple. And this question, my dear learners, is always on the question paper. It's going to be there on your question paper for final. So please make sure that you know the procedure on how do you solve this question. And then I think the minimum marks for this, it might be 5 and more. So really, we cannot be able to afford to lose those marks. Let's make sure that we collect everything. We collect every mark possible. Nature of roots. Nature of roots. Example, determine for which value of p will the equation this have non-real roots. Have non-real roots. So now under nature of roots, you must be able to be familiar with this table. You must know this table. If the nature of roots is two real and equal rational, real and equal irrational, real equal rational, and then the last one is non-real. But I will explain it later on how do we use this table. So it's very important to know this table because it's not there on the formula sheet. You must know that if your question comes under nature of roots. Now the solution, first we have to rewrite it in a standard form. You can see this in the standard form so that you can be able to see what is the value of A, what is the value of B and C, right? And then the value of A in this case is 3, the value of B in this case is negative 9, then the value of C is negative P. Then you will then calculate the delta equals to B squared minus 4AC. Then you substitute the values, then you're going to get H1 plus 12P. Now, we have to solve the value of P, but because it say it have non-real roots, you must know under non-real roots what is happening with the delta. I say delta is less than 0. The delta is less than 0. You can see this one, the delta is less than 0. So where you see the delta, you're going to be substituting with H1 plus 12P less than 0, then you solve the value of P. Then the value of P in this one is P is less than negative 3/2. That's how you should now solve the value of P under nature of roots. determine the value of d for which this 5x squared plus 6x minus d equals to 0 has equal roots. Then in this case, we'll be calculating the value of d. Then we first have to write, because it's already in the standard form. And then what is the value of a? In this case is 5, value of b is 6, value of c is negative d. Sorry, it's negative d. Then you then calculate the delta. Delta equals to b squared minus 4ac. Then you substitute the values there. And then after substituting your values, then we have 36 plus 20d. 36 plus 20d. All right. And then after getting the delta, we go back to question and we say has equal roots. You want to see the weights equal. Where that's equal, you can see equal appear where delta equals to 0. That's where the weight equal appears. Then it's going to be delta equals to 0. Then you then say 36 plus 20d equals to 0. You transpose this negative 20, 36 is going to be negative 36. Then you divide both sides with 20. And then this is what you're going to be obtaining. D equals to negative 36 over 20. If you simplify it, then it's going to give us negative 9 over 5. So that's how you should answer question under nature of roots. It's very, very important. All right. And you should remember sometimes they can say has an equal. So you must be able to know where does the weight equal appear where delta is equals to 0. All right. Then let's proceed. The formula for calculating the distance traveled by an object at time t second is given as s equals to ut plus plus 1 over 2 at squared. Make u the subject of the formula. So we have to make this u the subject of the formula. Let's see, step number 1. We are going to be transposing this part. Then it's going to be negative. You can see it's s negative half ax. This is not x, this is supposed to be t here. And then after we're going to be dividing with t because we want to make u the subject of the formula. This is what I did. I have divided it with t. Hence, calculate the value of u if the acceleration a equals to 3 meters per second squared. The distance traveled after 4 seconds is 36 meters. And then you just substitute the values there and then you press your calculator and then you get us equals to 3. So that's how you should now calculate the value. It's very simple, quiet. And then we have another one, which is the formula to calculate or to determine the resistance in a circuit. It is given as 1 over r equals to 1 over r1 plus r1 over r2. Express r as the subject of the formula, meaning we have to make this r the subject of the formula. So let's see on how do we do that. Now first we have this, then what is going to happen here? On the right hand side we are going to be looking for LCD, the LCD, which is R1 plus, multiplied by R2. Then we have this R1 into this cancel, this one left with this one. Then 1 times R2 is R2. And then plus R2 cancel R2, we are left with R1. Then R1 equals multiplied by 1 is R1. Then we cross multiply, and then after cross multiply, you divide, and then this is what we're going to be obtaining. So that is the answer. Then from there, the second step, they call it R, the total resistance of the electrical circuit. If R1 equals to 30 and R2 equals to 30, then we're just going to be substituting the values there. And then the answer is going to give us 30. So it's going to give us 30. So it's very simple to calculate that. Binary numbers. Binary numbers. Add the following binary number. Then it's going to be 1 plus 0 equals 1. That's number 1. And then 0 plus 1 is equals to 1. That's number 2. 1 plus 1 is 1, 0. So it's 1, then we carry 1. All right. 1 plus 1 is 1, 0. And then plus 1 is 1, 1. So it's 1, carry 1. And then this 1, you then drop it there. Then it's goes 1. So the answer for this one is 1 plus 1. I mean, it's 1, 1, 0, 1, 1. All right. That's how you should now add the binary numbers. They are quite, remember we did this binary numbers to increase 10, and then there were no binary numbers in grade 11 and 12. So you just have to go and remind yourself on how do we go about it, how to add the binary numbers, how to subtract binary numbers, or to convert from binary to decimal or decimal to binary. It's very, very important. Now they say write 36 as binary number. Let's write 36 as a binary number. The solution is what you're going to use this table, and then base 2. Then it's going to be 36 base 2. So you say the 2 into 36 is 43. There is no remainder, then it's 0 there. And then we say 2 into 43 is 21, because there is a remainder, you put 1. And then 2 into 21 is 10, there is a remainder, then you put 1. 2 is to 10 is 5, if there is no remainder, you put 0. 2 is to 5 is 2, there is a remainder, you put 1. Then 2 divided by 2 is 1, there is no remainder. Then 2 divided by 1, there is a remainder there. So after this, remember when you write this binary number, you are going to write it from the bottom to the top, right? Start from bottom to top. So it's going to be 1, 0, 1, 0, 1, 1, 0. So meaning 86 is 1, 0, 1, 1, 1, 0, 1, 0, 1, 1, 0. So this is how you should write you should write the binary number. All right. All right. Thank you very much for being with me on this very interesting lesson. And then I hope whatever we have discussed, you are going to be able to understand it while you are busy preparing yourself for this coming final exam. And then please let us make sure that we answer more questions as possible, so that we make sure that we are ready for this coming exam. And then I'm just going to leave you with these words before I can close this lesson, that says, never give up. Today it's hard, tomorrow will be worse, but the day after tomorrow will be sunshine. So let us make sure that we push ourselves, we work very hard for this coming final exam. Because if you start as early as now, working very hard, then it's guaranteed that you are going to make it at the end of the year. That's that. Okay, thank you very much. Have a nice Saturday. Bye.